Imagine a world darker than coal. Meet Trace 2b, an exoplanet that reflects less than 1% of the light that hits it. It is arguably the darkest planet we have ever discovered. Tiras 2b resides hundreds of light years away from Earth. It orbits a star known as Tiras 2, hidden deep within the vastness of space, practically invisible to the human eye. S2b maintains a dangerously close orbit to its host star, located only 3 million miles away. At this proximity, the planet's atmosphere is scorched, reaching hellish temperatures exceeding 1,000 degrees Celsius. A cycle of extreme heat and light consumption defines this scorching world. TRES-2b is tidally locked to its host star. Because it orbits so closely, gravitational forces have synced its rotation with its orbital period. This means one side of the planet is permanently bathed in intense, blistering starlight, while the other side is forever locked in a freezing, eternal night. The result is a world of extreme contrasts, where the temperature differences between the day and night sides create turbulent weather systems hidden beneath its dark, light-absorbing atmosphere. It is a place where time and position are one and the same. In astronomy, we use the term albedo to measure reflectivity. It defines how much sunlight a celestial object bounces back into space, rather than absorbing. Our own planet, Earth, has an albedo of approximately 30%. This is thanks to our clouds, ice caps, and atmosphere, which reflect a significant portion of incoming solar energy. Across our solar system, reflectivity varies wildly. From the bright, icy worlds to darker, rockier ones, every planet has a unique albedo signature. But then there is Teres 2b. This exoplanet holds an albedo of less than 1%. It is effectively a void, darker than coal, darker than black acrylic paint. It does not reflect light, it consumes it. Teres 2b is a true planetary titan. It is roughly 1.3 times the mass of Jupiter, a colossal gas giant in its own right. Yet this giant hugs its host star with incredible intensity, completing a full orbit in just 2.5 Earth days. Modern science, anchored by the James Webb Space Telescope, is now peering into the abyss. By analyzing the spectral light, we are confirming the presence of vaporized metallic oxides in the atmosphere of TARES-2b. This data reveals the chemical fingerprints of the darkest world yet discovered. Astronomers hunt for optical voids in the deep data from our space telescopes. This phenomenon occurs when a planet passes behind its host star, a moment known as occultation. During this secondary eclipse, the planet's light is obscured. Even if the planet is nearly invisible on its own, the total light we receive from the system dips, revealing its presence. This light curve plots the flux over time. That sharp downward spike represents the moment the dark planet vanishes behind the star, confirming an optical void. These subtle shadows are our primary tools for mapping the darkest worlds in the cosmos, turning light itself into a map of the invisible. The universe contains other dark worlds. Take WASP-12b, for example, an exoplanet known for its low light reflection. However, while WASP-12b is remarkably dark, it does not match the extreme nature of TARES-2b. With an albedo of less than 1%, TARES-2b remains the true master of darkness in our catalog. Darkness is not uniform. Far from being a static property, an exoplanet's ability to consume light is a complex variable. Experts suggest that an exoplanet's reflectivity shifts based on the exact temperature and the precise chemical ratio of its atmosphere. By analyzing the spectral signatures, we can see how molecules like water and sodium vapor act as sponges for photons, trapping light within the clouds. Every world has its own unique, light consuming signature. Darkness, then, is a fluid chemical performance unique to every planet. Because TRES 2b absorbs almost all light it encounters, traditional telescopes are blind to it. It remains invisible to the human eye. Instead of reflection, we map the planet's thermal emission. We effectively create a heat map of the dark world. Infrared sensors capture the faint, deep red glow emitted by the planet itself. It radiates energy like a cooling ember. By isolating these infrared signatures, we reveal the complex atmospheric structures that remain hidden to optical instruments. We don't see the light it reflects. We see the heat it consumes. The human perspective is a limited lens. We often believe what we see is the whole truth, but our eyes perceive only a tiny sliver of the electromagnetic spectrum. Most of the cosmic reality lies beyond these boundaries. TRES 2b exists in a domain that our biology is simply not evolved to witness. TRES 2b is a reminder that the universe is vast, mysterious, and often darker than our minds are prepared to imagine. It consumes the very light we use to navigate our existence. From the coal-black clouds of TAR-ES 2b to the glowing heat of its interior, this planet remains one of the most enigmatic chapters in modern astronomy.